Might as well do it, but yeah, because I
Yeah.
thought that the last one we didn't have to.
I don't think we have to, but I already started the broadcast, so we'll record it anyway.
Yeah, no
Sounds good.
problem.
Okay.
All right.
Post it anywhere.
Should we start on question 2? I can read it.
Yep, I'm just pulling it up.
It says, in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared education level, high school, undergraduate, master's, doctoral degree, of people who manage successful startup companies in the United States and Korea. You want to determine if education level of managers of successful startup companies is independent of the country they are from, United States and Korea. Which hypothesis test would be most appropriate for this analysis? What do you
Wow.
guys think?
I think the test of 2 proportions.
That's what I guessed.
That's what I would
Yes.
guess.
Okay.
All right. And that's exactly what we're talking about, our guesses here, aren't we?
Yes.
Yeah, which one is that? I'm sorry, it's pulling up still. What number is that?
2.
It's 2, okay.
Oh, well, no, it's question number 2. It's the last one.
Yeah. Sorry, I just don't have the answers up yet. My computer is running slow.
No, the last one is the chi-squared.
It would be the test. It's the second to the last.
Yeah, second to the last one.
Okay. And what we can do, because we can take this twice like all the others, right?
Right, I think
Yep.
so.
Take turns submitting
Okay.
Yeah, sounds good.
to make sure we get them all.
Mm-hmm.
Okay.
Okay. Then the next one, human resources manager. Sorry, I switched past it. Reported data from a recent involuntary reduction in force. You're the attorney. You want to determine if age discrimination was a factor. The company reported the number of employees in 2 groups: 40 years old or younger and over 40 years old. They also reported within these groups the numbers of employees who were terminated. You want to determine if both age groups were treated equally, which hypothesis test would be most appropriate. So what do you guys say?
Would that be the chi one?
That's what I thought.
That's what I put too.
You have 2
There's
age groups.
3 of us.
Yeah, you have 2 age groups and you have whether they were fired or not. So that's 4 numbers you're dealing with.
Yeah, so that's exciting if all 3 of us are thinking the same thing. So, yeah.
I'm like, either we're all really wrong or
Yeah, well, I put that because I just read that it was the independence of 2 variables.
Yep.
So
Well,
that's
chi. Yeah. Okay, I see what you're saying. Yep.
yeah.
Because that's what that is. Yep.
Yeah, I'll read 4. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be the most appropriate for this analysis?
I put independent sample t-test, and I guessed though.
I'm wondering if it is a test of 2 proportions.
And I put test of 1 proportion. Oh dear.
Well, and like I said, I was just guessing, but so what they're looking is if it is male heavy, because it says it's different than the proportion of males in the population is the only thing that caught me.
Oh, well, let's try. Yeah, we can try independent sample t-test. I'm okay with that.
Well, yeah, but I don't know, because it almost could be the 2 proportions, but the only reason I put that is because on this sheet it says the description hypothesis is the difference of the means mu1 and mu2 from the sample means x1 and x2. But
I also don't think that you're just comparing one thing to the sample population, really, aren't you? You're comparing just one thing, which is the heavy users. Is it greater than the population of the means?
Yeah, because I wonder if it's even like the 1 sample z test or something.
That's what I was thinking too. One means sigma known. That's what I wanted to ask you. Is sigma this like, or is
There's no
I don't
standard
really know.
deviation listed.
Right, and that's what makes me go, because the population wouldn't be a standard deviation. If anything, that's a mean, correct?
Right.
Yeah.
Yeah.
I
Let's
don't
try
think
the,
I don't think it's
let's
a
try the
simple
one
one
sample
sample.
Z. Yeah.
I don't think that's what it is, but that's fine.
Okay.
Because I'm gonna keep my other one on here, and then we'll see what it is. Okay, so we won't.
Okay.
I won't submit it the first time.
Cody, do you want to submit first?
Sure.
Okay.
Okay, question 5 is a student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise, the other lock turned counterclockwise. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They wanted to determine if one of the locks is easier to open. I guess paired samples because it's the same person doing the tests.
I would agree with that.
I agree with that too. So that's the one I would
Yay.
guess on that one.
Okay.
And then it's for the next questions, the confidence interval, which this one I'm not sure of.
I don't understand the difference on the confidence interval versus the test, because you're basically choosing the test to determine the confidence interval, right? I mean, it's
Right.
isn't it the same? Okay, all right. Just making sure I understood those directions. Okay, a bank employs 2 appraisers when approving borrowers for mortgage. It's important that the appraisers value the same type of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study?
I put the independent ones just because, again, they're all different. I mean, nothing, and it can't be 1 proportion or 2 proportions, but I didn't really know.
I put paired sample because it's the same property by 2 different people. And if you choose a property, that's going to determine, maybe not though, because what one appraiser does isn't necessarily, well, it is. I mean, it's tied to the other
that's true.
appraiser.
Yeah.
But I don't know if it's their results that are tied, like, or, yeah. So I'm not sure. What do you think, Jessica?
My guess would be paired samples.
Yeah, just because I didn't get that there was 2 appraisers. Let's try the paired samples one.
I'm looking at that, and my guess is paired just because of the 2 appraisers.
Okay.
Same properties,
I like
2 different appraisers. It makes sense. So.
Yeah.
Okay, in Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decided to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study?
I was thinking the 2 proportions, but.
Well, because the keyword difference in there, so it makes me think it's either 2 means paired data or 2 means independent data. The groups are independent of each other. The data, yeah.
Independent.
I think they independent.
Samples?
I think they would be. I think it's 2 means independent. Or do we even have that choice? Wait, that's the test.
Independent samples T, right?
T, right.
Yeah.
Let's try that one.
Okay.
I love that we're so confident on this.
No,
I know.
a lot of this
And I think we're going to be taking this test in the day.
Yeah, I
a lot
know.
of it is guessing because I'm like,
This is the hard thing, and if this is really showing what the test is going to be like, I'm really scared.
yeah, I am.
Yeah.
But let's not be scared till we get our results back. Maybe we'll
Right, and then we can study our results. Yeah.
Remember, there is 45 questions on this.
Oh, yikes. Okay, double stuffed Oreos are supposed to have twice the filling of regular Oreos. You and some friends decide you want to know if the true assertion by the company who makes them. You take samples of 55 double stuffed Oreos and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study?
I think you need to get a life.
I know, seriously.
And that's
Oh,
what
I'm sure this was their study for the design the study. I would have been willing to do that.
I was gonna say, I should have done this on the design of the study. I would have loved to eat the Oreos.
Yeah, me too. Confidence of this true mean filling of the Oreos.
So it's just
Compare it
comparing the
together.
two different types of Oreos.
So is it
I
the
think it's.
confidence for two proportions?
I
That's
don't think so.
Are you
I
sure?
think it's just a one sample Z because your null hypothesis would be that the mean is 3 millimeters. And you're saying is, well, wait, they're saying true mean. Okay, so then the alternative would be the mean is not 3 millimeters. You know what I mean? Oh, although it's not
would-
necessarily the population, is it? You're right, you're right, because you
They're
are comparing two
comparing it.
different
They're comparing the two.
Yeah, so that's why I thought that it says to compare two proportions is the two proportions one.
Yeah,
Because it
I
doesn't
think you're
tell
right.
you three. I didn't see anything about a quantity of. I know there's a quantity of cookies, but not how much filling. But
Right, right.
I'll put
I
down
agree.
the
It's not,
confidence
I don't
interval
think
for
it's the
two
one
and
mean.
see.
I don't think it's the one sample.
Yeah.
So then, did you guys decide you thought it was,
The bottom
they'd
one.
be independent
bottom one.
confidence interval for one proportion?
For two proportions.
Oh, whoops. Yeah, move down on the screen. Okay, so let's see. Confidence intervals talk about for two proportions. Okay, I'm still trying. Oh, yeah, to compare two proportions. Yeah, that would make sense. Okay, I'll buy that.
All right, question 9.
Which one of the following best defines the notion of the significance level of the hypothesis test? The probability of observing a sample statistics more extreme than the one actually obtained, assuming the null hypothesis is true. The probability of the type 1 error. The probability of rejecting H. Oh my goodness. What's that one called? Gall. The null hypothesis.
That's the null.
Sorry,
Yeah.
I'm like, all of a sudden I'm like, I know what that is. The word escaped my brain. Whether it's true or not, or the probability of a type 2 error.
I think it's the third one. Because the first one is the definition of p-value.
Yeah.
So it's definitely not that. And the
Okay.
probability of a type 1 error is the same as the p-value. You know, that is,
The p-value.
Yeah.
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 So I think it's rejecting the
think it's
null,
three,
whether or
too.
not.
Sounds
Okay.
good to me.
Great. Okay, yippee.
And then the next one is the p-value one. So it's the
Okay,
probability.
we just got that one. Yep,
Yeah.
it's the third one. And then 11 says, suppose you can create a 95% confidence interval for a mean and get 10 and 20. You've been told to report this by saying something like, we're 95% confident that the true mean is between 10 and 20. Exactly what does this mean? We know the answer.
It's not number
Because that was
4.
one of the themes. Yes, that's right. That's right. I believe it's number 2, just because I remember that one from, do you guys know? Or I can pull up that paper again that we reviewed with her. Just a second. It is, it means the one that they gave, which is very similar to this. She can be 95% confident that the true mean height of the trees is between 68 and 74. So is that by chance say that? Ooh, maybe not.
I was
Dang it.
thinking it was number 1.
I think it's number 1 too.
Okay, that's fine.
Don't ask me.
Yeah. I
Yes,
could be
because
wrong.
these others all say chance, and then the other one is the strange grow quickly, which we know it wouldn't be. Oh, here's another one. Here's another one that gives it. No. Okay, so here's one that says, this is the example. It's the very same question. You create a 95% confidence interval. This is on with Sister Chipman, and get 10
Okay.
and 20. You've been told to report this by saying we're 95% confidence. True mean is between 10 and 20. What does 95% confident in this context mean? And the answer is 95% of all the 95% confidence intervals actually contain the mean.
Okay.
Got it.
Deal.
So
Okay.
that's 3 questions.
Okay.
A simple random of sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town is P equals 0.3 or 30%. What is the mean of the distribution of the sample proportions? That was another one of those that I had to go over with her.
So what's the formula for that? Isn't it just 30 divided by 100? 30 over 100?
Well, the mean of the distribution. I think that's, isn't that the one where you use the formula z-score equals the sample minus the, because you're wait. What is the mean of the distribution? Okay, never mind. I'm wrong. I don't.
Mean of the distribution. That's where I think it goes back to back into our brain from before.
The very first section, huh?
Yeah.
So
And that's where I thought it was the value minus, value minus the mean.
But see, the thing that's throwing me off is we're getting a p-value, not a
Like a,
mean.
yeah, that's the unknown population proportion. So then it's like the p-value equals.
Oh, remember that if it's the unknown population, you know that it's 100 adults. So because that's a large sample size, the sample would be the same as the population proportion. So I believe it is the same. It's 0.30.
Yeah, because I have p hat equals x over n. I'll try that.
What'd you say, Jessica?
It's not p hat though. I would try 0.30.
Yeah, I mean, well, that's the same as x over n is p. I'll put it, and then if I get it wrong, and so then
Okay.
what's the standard deviation then?
I wish my kids hadn't destroyed my notes.
Yeah, I bet for you, because I'm sure what I wrote is not, I mean, you know, that's the way I think. So, okay, standard deviation. I mean, I've got the crazy long formula, but that's not what we need. Oh, do we have to use the SPSS? No. Because doesn't that give us the...
You get the z-score if we put it in the probability applet, right?
Yes, but we need the standard deviation.
Standard deviation. So I was just gonna see if I could
Doesn't
see.
the explore thing on SPSS, I know it gives you the mean and the median. Does it give you the standard deviation? We could just, no, but you need a data set, don't you? Okay,
Yeah,
never mind.
I don't think, let's see what we can see.
Oh, standard deviation of a random sample variable is x bar equals standard deviation divided by the square root of n. And our X bar,
X bar equals what now? The square root of n?
no, the standard deviation
Okay.
of the population divided by the square root of n. So this little
X
formula.
bar divided by the square root of n.
Yeah, can you see that?
Yeah,
See that? Okay. So I think that's our formula. So then isn't X bar
then
the same as 0.3, I think. 0.3 equals, and we're solving for the standard deviation.
and the square root of 100 is 10.
Yeah,
So then we times each by 10, right?
yep. So that would be,
So is it 3?
yes, that's what I got.
Okay, we'll try that. Oh, what is the probability that your random sample of 100 will have a sample proportion less than 0.25?
So then we put a sample proportion less than 0.25.
Probably.
Sample. And the sample proportion is what? That's the part I don't understand what sample proportion means. What is sample proportion?
Is that the, well, it's p hat is the sample proportion. And so that's like x1 over n1.
Okay, wait, P1, P hat equals sample proportion.
Yeah,
You said it's what again?
x1 over n1, I mean, is the first sample proportion. So p hat equals x over n.
Yeah. So then our X is 100. No, our N is 100.
100, and it would be equal to 0.25.
But you want it to be less
25.
than. But you want it to be less than.
So it'd have to be 24, right?
No, that's,
No,
it's the,
you want to know the
we want to know the probability.
probability.
So let's
Then.
see.
Okay.
What is that?
I know. I'm like,
That's from the other lesson, I think.
which? Unit 1, Unit 2?
No, like 17, lesson 17. I think.
Our most recent unit.
Well,
Well, unit, yeah. Recent
yeah,
unit. Not,
it's our, yeah, this unit.
okay, I'm looking. I don't know what it is.
Oh, you know what? We can put it into our Excel, into our one proportion or our thing, and then put X is what was X again? X is
X was no
0.3.
0.3. Yeah.
0.3, and n is 100, and so then what could we? Well, I guess we couldn't do that though, because I was thinking you could put it into your applet. I think I'm trying to not do the work.
Well, yeah, there's no sense in having to do the work if you don't. Okay, is it a one proportion test, you think?
Let's see.
Yeah, because it said, what is the, I think it is, what's the question again?
What's the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
I think so, because a one proportion test is to find the true proportion of the population from the sample proportion, p-hat.
Mm-hmm.
And so then you'd use your Excel spreadsheet, which I can pull up.
Yeah, that's the one, but then it doesn't give you,
We don't have enough data. Okay. Proportion.
So our answer on 13 is going to be wrong.
yeah, if we do that, if the X is 0.3, then our standard deviation is 0.05 or 0.55.
She gives us options in the homework and has identical questions. Not in the homework, but in the chapter review. I just
Okay,
don't
so
have answers to it, but it gives us 4 options for answers for each of these.
all right. Is any of those where we're headed or not?
So on 12, our answer is nowhere close. On 11, our answer is one of the options. On 13, it's 0.138, 0.124, 0.876, and 0.862 are your options.
It's the same question?
No, I'm just saying for 12, we already have the wrong answer for 12. I can tell you that right now.
Okay, so
we did 12 wrong. 11, we have our answers. One of the answers that she has is an option.
Okay.
But she doesn't give us the answers to the one in the chapter, does she? Review. Nope. Okay.
Mm.
so let's do 12. So then what is the mean? If we put the one sample in, then well, it doesn't show us the mean on there.
I'm a little baffled.
Should we do the standard deviation that it says on there? I can't imagine that mean is not the right. I can't imagine that 12 is not right, but
I'm sorry, I haven't had a chance to write new notes, and my kids destroyed my old ones, so.
but I can't remember how the
on these.
What is the ability? 0.
So I'm pretty sure we have 11, right?
But see, this doesn't make any sense to me. Oh, that's the population proportion. And it's asking for mean. Okay, I guess I'm looking at, but I thought that, oh yeah, because what I was telling you is X bar, which is, well, that's a sample,
yeah.
right?
Mm-hmm.
X bar sample mean is the same as the population mean. Population proportion. So then, isn't that true that the p-hat is the same as p?
Yeah.
Yes. Okay, so then I don't know how that answer would be different.
I know. I think it's I think 12 is probably, and the standard deviation is
12, this 12, let me see if this 12, I'll read the 12 off of here. Tell me if it matches
All right.
It says,
Okay.
what is the standard deviation of the distribution of the sample proportions?
Well, that's not even the question. This question is, what is the mean
Okay.
of the
Some of
distribution?
them are exactly the same. So
The next one asks, what is the standard deviation? So
what's 13? Will you read 13 on the quiz?
yeah,
What
it's
is the standard deviation of the distribution of the sample proportions?
All right, you know what I say? I say, well, yeah.
Let's just leave it our answer and see, because these are similar. Some of them are identical. I guess this one's different.
So I'm just trying to remember what the formula is for 14.
I think that you do consider it as a one proportion z-test.
Right.
So I opened up Excel and I put it in there and I changed the null hypothesis to 0.25.
Okay,
and I
that's
typed
what.
test is less than.
0.25.
So then my p-value on the bottom came up as 0.
Well, but that's a different question than the.
I thought you were asking about 14.
Yeah, I am, but I'm wondering if that's still it's because 14 is really, I mean, it does change things. You know, than when you just do. I don't know. So then, what is the probability then? P hat is so it's 0 point. So 14 would be 0.003.
No, I think it's just 0. Based on me having put it into Excel. Tell you what, let me show you. I'll share screen here.
No, I have the same thing up, but I was just trying to see. So the probability is the p-value then.
Yes, I believe so. Is this what yours looks like?
Let me see.
Because I did the one sample z-test for proportion.
Yeah.
And then I entered in the stuff for the blue cells. Now that's assuming that, well, we're assuming that the X is correct.
Yeah.
And like I said, I changed the null hypothesis and changed the type of test to less than. And then the very bottom one, it says one proportion z-test. That's where I pulled the p-value. Isn't that correct?
I was wondering if it was p hat is the probability.
I see what you're asking. Let me read the question again.
Because probability is not the same as the p-value, I thought.
No, I think probability is the same as the p-value. Because the probability, p-value's definition is the probability of getting a test statistic as extreme as the one you calculated, blah, blah, blah.
Okay.
So.
All right, well, I'll put 0.000 in, so, okay.
All right.
Let's go on to 15. Can we put this then in our two proportion one? These numbers?
I don't know, I haven't read it yet.
Okay, I'll read it. Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into two groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true population of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril.
I think that's a chi-squared test. Am I wrong? Yeah, I'm wrong. Two proportions.
I think it's two proportions. So like X1.
All right, are you going to pull up your Excel or am I?
I have it pulled up too.
Okay,
so.
then I'll tell you what it says again.
Okay.
So it said of the 1,563 subjects that received Acupril, of those 1,563, 61 were dizzy. So didn't they say let P1 be the people who experience dizziness while taking Acupril? So that's the correct number that I just gave you.
61 is
61.
X1.
Mhm. No, yeah, or P1 or whatever.
Yeah.
Mhm.
And then
And then P2
out of
is
579.
no, the 61 is out of 1563 is the total who got, oh, I'm sorry, you're right, 579 who actually got the drug.
And then
No, 1563 received Acupril. And of those 1563, 61 were dizzy. Then 579 were in the control group who did not get Acupril. They got a placebo. That's the total number. 579 was the total who got placebo. And of that control group, 15 were dizzy. So P2 is the true proportion of people who were dizzy but did not take Acupril. So P2 would be 15.
and then N2 is 579. So N1 is 1563.
Yes, yes. And they want a 95% confidence interval
Yeah.
for P1 minus P2.
Okay. So X1
then-
is 61, N1 is 1563, X2 is 15, and N2 is 579.
Yes.
And P1 minus P2. Okay, it even says that right there. So the margin of error, is this
Yes.
where we add and then divide by 2?
No, I think it's just what it says on there because it's going to, well, let's see. It wants to know.
The margin of error.
Yeah, I know. Oh, the margin of error is where you put the two answers, isn't it?
That's what I'm
So
saying.
that's your confidence interval. Sorry.
Yeah, to put the 0.03 minus or plus, and then divide by 2.
Well,
0.
okay, the margin of error is the upper bound minus the lower bound divided by 2.
Yeah.
Okay, so then what's the upper bound? I don't have.
513. Upper bound is 0.029 and the lower is negative 0.003.
Negative
that again.
0.003.
0.003 negative.
Okay.
Okay. Two 9 plus
And what was the upper?
0.029.
0.029. Okay.
I got 0.016.
So why wouldn't you just or add the 2 and divide them by 2? I don't get it.
I did.
When we did that before.
Didn't you say 0.029 is upper?
Yeah.
And then I'm subtracting a negative number, so I'm going to add the lower one. And I thought you said that one was 0.003.
Yeah.
So when I added those two together, I got 0.032. Then I had to divide that by 2.
Okay, because I just put negative. See, this is where I need to learn if I'm doing it right. Negative 0.003 plus 0.
No. It's upper minus lower divided by 2. That's what messed us up on that last quiz we took.
Upper minus
Upper
lower
minus
divided
lower.
by 2.
Yeah.
Okay.
So that takes care of it. If the lower one is negative, it ends up being that you're adding them.
Okay, so what did you get?
I got 0.016. What do you guys get?
I get when I do that.
Okay. And so the lower bound is the negative 0.003.
Yeah.
And then the upper bound is 0.029. All right. Question 18. It's just the hypothesis is P1 equals P2 and the alternative is P1 is not equal to P2, isn't it?
I agree.
Yes.
So the first one?
Yes.
Okay. So, and then it's still going on our dizziness thing.
Yeah, wants the value of the test statistic.
Is the Z
Yes.
1.458?
Okay, and you have it up, and no one else does, I don't think. So 1.458.
Correct.
Okay.
And then the p-value is 0.928.
0.928.
Right. And so it's larger than the alpha.
Right. So we will fail to reject it, correct?
If the null is if it's low, give me 2
If
seconds.
it's low, you reject it.
Reject the null, and so it's large, so we fail to reject.
Yep, you're right. So
Okay, is there sufficient evidence? So there is sufficient evidence. The answer would be yes. And then I accepted the alternative. Wouldn't you agree with that?
You just, yes, I failed to reject the
yeah,
No.
yes, I failed to reject the null.
yeah.
Wait, that's me there.
That's right.
Yep,
The first one. No,
Yeah.
the
No,
yes
it's the
and
fourth one.
down. Yeah. Wait. Yes, I failed to reject the null hypothesis. Got it.
No, I don't want to put these in.
That's right.
Okay, so is this one going to be, this is a chai, correct? I want to be sure to do this one just to make sure I get them right.
So this one is a chai one?
I think so, just because of the way this is. Looks like
Did you
Table?
get your Excel working?
Yeah.
Yes.
How'd you do that?
We had pulled up the wrong, we pulled up the right one, but the right textbook, it needed to be 221A.
Like at the top of the lesson, there was a little spot up in the upper right corner where you put what class it is, and it said 221B, which is really what we're in. But in order to make the Excel show up, we had to change it to 221A.
Oh, well,
Weird.
good to know that.
Yeah, that was kind of
We're
weird.
gonna know to do that because we hit the link on our course.
Yeah, we didn't even have a link, though. That was what was so odd, huh?
Well, no, I'm saying on lesson 17, on those lessons,
Well,
you
that's true. The
hit
other
the
one.
link from the textbook. We shouldn't have to select which course we're in.
Well,
Okay.
you should be able to select the correct course that you are in. We're in
Right, instead of an alternative one that we're not even in. You're right.
Well, what I'm saying is it shouldn't even give us other options.
I
That's
know.
what we're in, that's what it should give us. That's what's stupid.
I agree.
Anyway, gotta love it.
Okay, so I put this data into the chi-square test. I can't say it.
Okay.
Mhm.
So are you doing the same thing, Naomi?
I am. And then I'm just looking to see, though, I don't get my chi-square test statistic or p-value because I think I have to change the, it's trying to sum too much data.
Yeah, I had to delete the other data.
Yeah.
But it seems like my test statistic is huge. Is it supposed to be 45.149? That seems big.
Yeah, that does. Hang on, I'm still working on mine. P13. Okay, that's P13.
Hey, honey, there's sour
I came
cream
up
in
with-
there too. There's sour cream.
What did you have for supper?
I gotta get Casey in a minute.
We had taco salad. Can't he go get Casey?
Oh, he just called, or she just called, and she's not quite done with work yet. So
Oh, well, that works out good. I
Yeah.
got a test statistic of 6.579.
So did you Let me
Here's
see
what
what
I'm-
yours looks like.
Will do. Just a sec. Share. This is so cool. This is so cool now that we know how to do this. It's just really cool.
I know it really helps, huh?
It does when you're with several people. Okay, so I'm going to make it big. So did you enter your stuff over on the left side in the blue, correct?
Mm-hmm.
Okay, then what I had to change, do you see, you can't see my finger, right? You only see the
No.
actual. Okay. What I did right here, where I just highlighted, I changed it. If you look up here at the top of the bar where it says sum equals sum, it's kind of in the middle above chi-square test. It's a big white bar.
Uh-huh.
And so it said equals sum, and it said M12 dot colon R17 or something is what it said.
Right.
So I had to change it to only include those 2 rows and only 4 columns.
Oh, so what do you change it to? Like,
Well, it was P13 because that's like if you're looking at up here and you see it's P, and then over here 13 you see is how far it goes. Did that make sense? Did you see what I did on my screen?
no, do that again.
All right, so I highlighted the last over here 13. You see how it has a big blue bar all the way across? So that's the
Yeah.
last column or last row of data I have down here under these chi-square sums box.
Uh-huh.
Which is on the bottom. Okay, and then I just sort of made a guess. Oh, okay, good. So P was right and 13 was right. So P13 is what it has to be up here. You see the sum?
Yeah.
So the first, yeah, M12 through P13. Does that make sense?
Yeah. But I'm
Okay.
just wondering why I couldn't just highlight the data that I have and
I don't know. I don't know. I just know that when I changed it, I got a number and see if it, I mean, I don't know. Does that make sense? And does it?
formula.
Isn't this supposed to tell you if there are 0 values that, Does that seem like a reasonable test statistic and p-value? Degrees of freedom, those seem reasonable.
Yeah, but I'm still confused on how you did that over there, because mine, so you just go to the bottom of that
Of
over
this. Yeah. So if I see that, I can see that it's highlighted a P and a 13, but just to make sure I can touch on the P up in the big gray column. So
Uh-huh.
that's for sure that. Let's say I think it's a 12. Oh, no, see, it must be 13. So then I highlight on 13. Well, maybe. Off the 13 column, and I see that that's the correct one. Jessica, are you working 4 answers ahead?
No, actually, I'm not. I had to go grab my charger because I'm at my parents' house and I'm using my phone as internet right now, and it was critically low and yelling at me, and I was like, "Don't shut down!"
That's right. We're counting on you to keep us alive.
Yeah,
All right,
like,
you guys-
Yeah,
Okay.
mine still isn't. I'm gonna have to play with that because
Share your screen. Share your screen. Let's see what you got.
Okay.
Whoa. Why is this doing this craziness?
Okay. So that's what I've got, and see, mine is over here at the test statistics. So if I go over here and do this on P30, or then it gives me some funky chicken number over here. Here, I'll delete.
I don't know what you're doing. Wait, no, you click on the test statistic box in your chi-square test.
Okay.
Okay, click on that now. If you look at the bar, the big white bar that goes completely from the left side to the right side. Whoop, I lost you.
Okay, right here. Am I still right here, the where my X is?
No. Okay.
Don't go to the bottom here.
I only, yeah, you were there. You were there. No.
Just where there's nobody there,
click-
nothing there?
Click back on test statistic number that you have.
Okay.
Okay. And then do you see where it says chi-square test on the left side? And then it says, please enter data in blue cells. Don't do anything. Just tell me if you see that.
Yeah.
Do you see the words chi-square
Oh, yeah,
test?
yeah,
Okay.
yeah. I see it right
Oh.
here.
Go above that until you see the above the E and the D. Yes. Now that's including extra cells, so it must be counting them as zeros or something crazy. So that's where I was telling you where you just are highlighting, and it's only the chi-square sums that are down here.
Okay. Can I
Not
just
using-
hit enter now? I hit enter
No,
and then go in.
You have to change your M12 to R17 is too much. So
Okay.
where your little thing was just blinking, exactly. Whoop, M12.
To see, I wonder if wouldn't I go over to like C?
I wouldn't highlight anything. No, it's the M. Okay, if you look at where M12 is on your,
Yeah.
that's the 5.658.
Oh,
number.
okay. Yeah. Okay. I can see it over
So
here in
you
the
need-
chi-square sums.
Right. You need M12 through P13. No, that I think it's a colon that you put between the 12 and the P.
Or not
think. No.
P13.
Well,
like
yeah.
that?
Well, no. Yes. Do you understand right now? Do
Yeah,
you see
yeah,
how
I
you're?
just understand what, and then I can hit enter, right?
Yes.
Why does it
Oh,
still say
shoot.
45.145?
I don't know. Let me look at mine again.
M12 through P13, my sum
Yeah.
is still the same.
Yeah, and I can't see anything you're showing me. My screen on when I go to the messenger, our show is locked up, so I can't even see what you're looking at.
Oh, bummer. Okay. And I'm just
What
checking
did
your
you-
data is correct.
What
Oh,
did you
no, you know what,
test?
Cody,
Yeah.
column, like where you input your raw data,
Uh-huh.
column 4, row 2, you have 90. And Jessica, can you tell us if it's actually 190? Is mine right or is hers
It's
right?
190.
Oh, 190? Okay.
Yeah.
So that's going to change things for you.
And the
Yes.
rest of them,
Are correct. At least they're the same as mine.
I can
and
tell
then,
you
so then I have my test statistic is 6.579. Is that what you have?
that's what I have.
Yes.
Okay.
Yes.
All right. Okay. Then
So
I'm
just an
going to.
input error. That
Man,
was
I
easy
love
enough.
I love these little apps.
Yeah. So then the p-value, I believe, is 0.087, correct?
Yep. Yep.
6.579 is our test statistic. Okay, let me try to click back.
Why didn't it ask for degrees of freedom? Dang it.
I don't
I
know.
know, right?
Easy point.
The next question after that isn't hard though, because you put the p-value in and then it just wants to know should you reject the null or not and explain.
So on question 23, do we go 0.087?
Yes. And then that number is larger, so then we will fail to reject. So should you reject?
My guess is no, the p-value is greater than 0.05.
I think that's right.
Because it says explain, and that explains why you wouldn't reject it.
And then, so we did not reject the null, and so we have sufficient evidence.
Oh, wait, we did, yeah, wait, should you reject the null?
No,
No.
because it's
Fail
about,
to reject.
yeah, we failed to reject,
Yeah.
which means you have sufficient evidence to say that being a morning or evening person is independent of age.
So number 2.
Correct? Am I right?
Hold on. Let's
That's
see.
how I read it, but
I'm still having trouble with that last one here in my
Oh.
screen and trying to. Okay, what do you conclude? We have sufficient evidence that being a morning or evening person is not. That's right. This is, whereas the CHI test, it is not independent. It's, yeah, that's the correct verbiage. So let's see. Let me say. Oh, I didn't write that down, but yes. So let's see. We have sufficient evidence to say that being is not independent. So it'd be the first one, correct?
No, because it's saying that we failed to reject, right? Because the
Oh, if we
hypothesis
reject,
is being a morning or evening person is independent of age.
no, I think that we have insufficient evidence, correct? Or do we have sufficient evidence? I think we have insufficient if we fail to reject it.
Depends on how it's worded. Let me read again.
If we reject the null, we have sufficient evidence to say blah, blah, blah. If we fail to reject the null, we have sufficient evidence to say we have, okay, where did I? Insufficient evidence. Wait, I wrote that down wrong. Forget what I just said. Fail to reject, we have insufficient evidence.
Yes. So, and it's always on these CHI ones, it's not, it's the alternative hypothesis is that they are not independent. The null is that they are.
Yeah, but we failed to reject, which means it should be the second one. We have sufficient evidence to say that being a morning or evening person is independent of age.
No, because if you, wait. Oh, now I'm so confused.
If we fail to reject, we have insufficient evidence.
That's what I think. And the number 0.87 is larger than 0.50, correct?
Yes.
Okay, so then that means that we failed to reject. So when you fail to reject, you have insufficient. I would agree with Cody. I think it's the last one.
So it's insufficient if you fail to reject.
Well, is it insufficient to say that we have independent or not independent?
The alternative is not independent.
Okay.
But the alternative is independent.
Yeah.
I mean, the null is independent. The alternative is not independent.
Okay.
Wow, this is like a crazy trickiness.
All right. So
Next 8 questions.
a recent book noted that only 20% of all investment managers outperform the Dow Jones over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs were followed over a 5-year period. 50 of these outperformed the Dow Jones. Let P be the true proportion of investment managers who graduated over a 5-year period. Okay. So P is what?
True proportion of managers who graduated, who outperform.
So would that be the 50? P equals 50?
I'm reading
Or
this again,
P
sorry.
equals 200. No, that's a random sample.
Random sample of 200 from one of the countries that were followed over 5 periods. 50 of these outperformed. So P is 50.
Yeah.
I believe.
Yeah. Okay.
But that's no. It's a proportion, so it has to be 50 out of 200, doesn't it?
Yes.
Okay. So then that would be 0.25, if my math is correct. My math, I don't trust my math. Let me check it. Yeah, 0.25. Okay. So, and then the 20%, that's like that would be, that's interesting. So it says P is the true proportion, but I thought that would be P hat, because that's our sample. I don't know, you're basically comparing it to 20%, right?
We have
So which test are you using?
over 200. Give me a second. Our
Okay.
confidence interval is 95%, right?
Yes.
Yeah. So if we put it in the one proportion, we could put X is 50, N is 200. Our null hypothesis is 0.20.
Well, X isn't, oh, yeah. Okay, sorry. Okay, I see what you're saying.
And then is it greater than because it's outperformed?
Yes, I would agree.
So if you put all those numbers in, the lower bound, I mean, it gives you that in the one proportion.
Just, I'm going to double read it again. Okay, let P be the. So what is it you want to know? Recent books noted that they outperformed Dow Jones average.
You know, the lower bound, right?
I'm just confirming that it is a greater than thing and not just a not.
Not equal to.
Right, that's so just I'm rereading it. Let's see, this random sample of 200 was followed. 50 of those outperformed the Dow Jones average. Let P be the true proportion of these who graduated who did outperform. So, yeah, I guess it would be greater than.
Oh, yeah, that's confusing though.
It is kind of confusing the way it's written.
Confusing.
So the lower bound is 0.190.
Let's see.
What'd you
Where's
get?
sorry, yeah, I'm like thinking, where is it? But yes, 0.190, I agree.
And then the upper bound is 0.310, correct?
Let me look again. I'm having to switch back and forth. Yes,
So what is it?
0.310.
Zero.
Yeah, sorry, I'm jumping back and forth between the two.
Holy camole, I don't even remember how to do this. Suppose you'd been, this is 28, been in charge of designing the study. What sample size would be needed to construct a margin of error 2% with 95% confidence? Use the prior estimate of P equals 0.2 for this estimate. Oh my gosh. Okay. Oh man, I don't even remember. So this is in our third unit of material, right?
Sample size would be needed. Let's see.
Sample size. So you're solving for N. So I have one formula that says P hat equals X divided by N. That's P hat. Is that the same? But P hat, we know the mean is the same as P.
Is this not something we can put into our,
I don't think so, because you're trying to get a sample size. Okay, let me ask you guys this. Is this similar question to this sample one that she and I went over? I'm going to read you the sample one that she and I went over. The State Highway Patrol recorded the number of speeding tickets given to drivers each day. They found this number to be normally distributed with a mean of 69.5 and a standard deviation of 7.3. Use this info to calculate the 90th percentile of the number of speeding tickets given. So, is that the same kind of question? Because
What formula did she have you use?
She said when you have a percentage, like the 95th or the, no, I guess not, because this is 90th percentile of the speeding tickets. Never mind, it's not. Because you need a number there, and this is,
Where?
no, this is different.
There's got to be a way to do it in the, have Excel do the math for you.
Okay, in this formula, I'm just asking you. Okay, can you see this little tiny formula to the side of my dirty fingernail? Sorry. Do you see that?
Yeah.
Okay, what does X mean in that formula?
I can't see it now.
Oh, it was P hat equals X divided by N.
X
What
is
about-
the number. I mean, X is. Give me 2 seconds. I'm trying to remember. I know what this is. It's. Oh,
Is that the sample
X
size?
100 is how many you sample. You know, the bottom number. So N is
Yeah.
how many you sampled from, and X is the number of people that answered that whatever question you asked. Does that make sense?
Yeah.
But it was N is 200.
Yeah.
And so we need to figure out, just a second.
Well, I'm thinking, but then I don't have a way to put the margin of error in there.
It's on a quiz. Which quiz is this on?
I cannot remember at all, you guys. I really have no clue. I don't remember.
This one quiz just not too long ago.
Let's skip this one and go on and do the next, okay? Because we still have more to do. Unless anybody else has an idea how to do it. I'm confused. You guys know or not?
Okay.
You can move on. I'm gonna see.
It's not there. It'll still be a minute. I'm still trying to go through this, and I don't know where Robert's at.
Can I X out of it?
Okay, bye.
Did you show that to Rob? What do you say?
All right, so what did we decide?
I think we're going to move on. Just put like a 0 in there because I have no clue. Unless you guys have a clue, let's move on to the other questions and see if we can't figure them out.
Leave it blank and let's move on. We can.
Okay. Suppose you wish to see if there's evidence that graduates of one of the top 10 business programs performs better than the other investment managers. Conduct a hypothesis test. Use a level of significance of 0.5. So, okay. Evidence of graduates, top 10 perform better than. So, are you comparing? Let's see. Let's look at all these. So, it's all P's.
Yeah, P equals 0.2, and so that has to be our null, which is P equals. And then it has to be greater, like the second to the last one.
It's better, yeah. Yep, I agree.
And the first one is the measurements, right?
First one. Are you talking about, oh, the next question.
Number
Question
30. Yeah.
Okay. P hat. Yes. So I think that would be NP is greater than 10.
Right.
And N times 1 minus P is greater than 10. So, my computer is doing some crazy things.
So
I try to
is the value of our test statistic, didn't we already do that? So we have to figure out what that one question is.
Oh. Oh.
Oh. That can't be it.
Hmm. Yeah, you got to get the test statistic and the p-value. So you're right. We've got to figure out a way to get it in there. Okay. Go back up and read that again. What sample size would be needed to construct a margin of error of 2%? The thing that's kind of throwing me off is this margin of error of 2%.
Give me a. I think I might have found the formula to figure the one we skipped out.
Okay.
Let me see if this number even makes sense as soon as I figure it out. I'm like, I just want to make sure it's
Reasonable, yeah.
because if it's not even a reasonable number, then obviously I'm wrong. But what was the P on that one? Did we have the P hat? Yes. Okay. Sure. 0.02 times 1 minus 0.02. Okay. Sorry, I just need to figure it in the calculator now. Because don't we need this number to move on?
Yep.
Yes.
Yay.
Unfortunately.
Hang on, I'm going to go see if my husband he's still here. If he can go get Casey, I'll be right back.
Okay.
Sweetie butter, is there any way you can get Casey? Still at school. He won't be back in 3 hours.
Wrong number.
Is your family getting tired of you always being tied up with this class?
The fact that it's one class, yes.
Yeah.
We're pretty used to me being tied up with school, but one class I did not think would be this bad.
Right.
That's like driving me crazy. Told my
Yeah.
dad tonight, I was like, this class is worse than my nursing school.
Yeah.
Okay, so the
This is
number
bad as
I,
yours.
yeah, it is. The number I get is 3.76.
Okay, Robert's going to get her right now. So
The number of how many? I know there's
Right, but remember, even when we did that before, you just have to round up because you can't have a part of a person. So a 4
Okay.
would make sense. That seems kind of small, though.
Just
Okay,
give me a
what-
second. I just remembered how we did it last time. Give me a second to do the math now. I did a different formula. Let me do this formula. I just found the right formula, I think.
Well, tell
What's
us
the
what it is.
formula?
and we can
N
do it
times
again.
P hat, and then you go equals 10.
Equals
So-
or it's greater than or equal to 10.
Yeah, greater than or equal to 10. But you just pretty much do the equals. So P hat and 10. So you go 10 divided by what's P hat? 0.02?
0.250.
0.25.
But what's P hat?
Wait.
0.250.
Well, no,
Oh,
they're saying in this case, P is 0.2 for this estimate.
Okay,
Use the
got it.
prior.
Okay.
Oh, okay.
Okay, so I get 50.
That would make sense.
Because so you just put it in that formula that NP greater than equal to 10. At least that's
But what does the margin of error? What does the margin of error of 2% have to do with anything? Is that just thrown in there to confuse us?
Well, we're changing it. See, it's trying to. What was our margin of error before?
I don't know. I don't remember. Let
I
me
really
look.
don't know.
Because the thing is that is our,
Margin of error 0.02.
our margin of error is, if we did what before, 3.10 minus 0.190.
Divided by 2. That's right. It was 16%. So this one is, no, it was like a 1% margin of error because it was 0.016. I don't think that's the right formula.
Okay.
But
I think
50
the one
kind
we've
of
done in the past.
50 wouldn't be it because X is 50.
Yeah, I mean, we know that that's what they used for the other one, so that's what makes me wonder if it's a margin of error of 2%.
So that's what I was saying. If it's a larger margin of error, then it is a smaller number.
So here it says we can determine the sample size we need to obtain a desired margin of error using the formula. I just found this. I don't remember which chapter this is.
Okay.
Using n equals, what's the z with the asterisk thing?
Oh, that's where we get it. That's using that, special number that you put in for a 95% confidence error, or is that 1.96?
Okay, so that's what I used. Divided by m squared times p hat times 1 minus p hat. So I did that and I got 1,536.64. 0.64.
Okay, let me see.
So is that the formula we use? Because that's what it
I don't
says.
think so. I think it's this formula. You kind of got me going, oh, wait, I have a formula like that.
Yeah, there.
I think it's this formula. Can you see it?
Go back
No.
a little bit.
Back up.
It's still locked up. I can't see anything you
I
guys are
can't. Well, and I can't. I can
Okay,
see what.
I'll read it to you. It's
Okay.
N equals Z asterisk times standard deviation. Isn't that the mu symbol? No, that's the mean. Sorry, mean is mu. Or is that the O thing with the line over it? I should know that by now. That is standard deviation. Okay, so sorry. N equals Z asterisk times standard deviation divided by M, as in margin of error. That
Okay.
whole thing gets square rooted. I mean, gets squared.
What gets divided by m?
Oh, yeah,
All
yeah.
of it or just
Here,
the
I'm going to rewrite this formula, okay, really big.
Can you just take a picture of it and maybe can it just unfroze?
Here, I just wrote it real big. Does that work? Oh, you can't see, can you, Jessica?
It just barely unlocked. So did just seriously barely did. See?
Okay, can you see that?
Yeah.
That we have all the information we need, don't we?
And then we have to solve for M, right?
But no, we're solving for N as in the number of people that you need. The M,
That's right.
And we have the margin of error already because that's the margin of error, right?
yeah, well, it's the one that they're telling us, a 2% margin of error. So that would be 0.02, correct?
Do
Correct,
that.
yeah.
One.
Okay. And then what I'm not sure on is the standard deviation. What is it? Is that our P? Is our
On this
0.
one, yeah, because on this one it says the standard deviation is 0.0283.
Well, it's saying on here, use the prior estimate of P equals 0.2 for this estimate, which I don't know why it only has one decimal and not 3 like we had. Oh, Jessica, yay. You got us, I think, moving in the right direction.
So what numbers are you punching in?
On the top, I'm doing 1.96 times 0.2 divided by 0.02, and that answer I will then square.
Okay. What do you get?
That's making sense.
Yeah, it's making sense.
Oh, this seems weird. It's a really big number.
Yeah, but you times it by 1.96, right?
Well, maybe I did it wrong. 19.6 is what I had, but maybe that was what was wrong because this is a really big number. Maybe,
What
and
number did
just
you get?
Well, the
384.16.
95% would be 1.96, so I got a 3.96 number, so that can't be right.
1.96 times 0.2 equals 0.392 divided by 0.02 equals 19.6 times 19.6. Yeah, I'm sure it's the whole thing is squared. So I get 384.16. That's a really large sample.
Well, this chapter, it's a summary, and it flat out says, I don't know.
What? Go
It
ahead.
says we can determine the sample size we need to obtain a desired margin of error using the formula. And then here, sorry, I'm going to go back here, and it says to use this formula. See if you can read, you can't read it. Let me rewrite it larger.
Okay.
Give me a second to grab a paper. Because it flat out says that's how you do it.
So do you think my formula is wrong?
I'm wondering if, so my number's like half the size your number is.
Well, your number or your formula, if it is m equals z squared times standard deviation divided by square root of n, it's the same as my formula. It's just reconfigured, if you know what I mean.
Yeah.
So what figure are we doing?
If it were the same, we should be getting, if it says
The
a
same
p
answer.
asterisk, they mean p hat. What is the p asterisk, actually?
I think that I
Point
don't know why they're
estimating.
saying asterisk, but
I have written in my notes something about everything to the right of the plus or minus is the margin of error. Can you put this into the applet?
no. I don't think so. Oh, just a minute.
I'm frustrated.
All right, let's see it. Back it up just a little bit.
I'm sorry. I'm trying to look underneath it. Can you see it now?
Okay. Holy cow, where the heck did that thing come from?
Let me see it again.
It came directly from the summary of this of a chapter. It says n equals the z with the asterisk over m, divided by m, times p with the asterisk times 1 minus p with the asterisk. And it says p with the asterisk is your prior estimate.
Okay, well then
P.
that's, I think you have the right formula because that number is what she gave us in the
And then
equation.
it says if no prior estimate is available, the formula is z asterisk divided by 2m, and all of that is squared. Does that make
Well,
sense?
that's what yeah, z asterisk divided by
2m.
2m, and all
So
of that is squared.
So that'd be 1.96 divided by 2 times 0.02, right? And all of
Yes.
that's squared. So let's see what number we get when we do that, because
Okay.
we
That's a
don't
heck of a lot easier.
have a point estimator, do we? A prior estimate for P.
Yeah, it's 0.2.
Yeah.
Oh, if it's 0.2, then we got to use the other one. So we go 1.96 over m, which is 0.2.
And then the p.
And your
No, M, what is M? M is
That's our-
0.2, yeah.
Yeah.
0.02.
Yes.
Right.
And then P should be 0.02. 0.2, right?
Times 1 minus
Yes.
0.2.
Okay, now I get a number that I think is a little more reasonable.
Oh, and that's squared. Oh, sorry, I forgot squared. The z asterisk m is squared.
Well, I thought, oh, is squared? That part is squared?
Yeah, it's still squared.
Let
I
me
forgot
see your
to write
formula
that down.
again. Look it up. Let me see it again when you fixed it, just to make sure I got.
I still need to run my math for this.
Okay, back up just a smidge.
It's
Oh, okay. Well, then that's going to change everything.
yeah, I know. I
Okay.
just realized that when I looked at it, I was like, ah, dang it! I gotta redo it, all of it, because I
So-
just figured it out.
Yeah, I didn't get that. What chapter is that in the summary?
I'll have to just a second. I'll have to look it up because I do not remember.
I'll look
This
in
is one of the
this,
many
I
things you
have-
had printed.
Yeah,
Yes, I have.
I have every chapter printed, and I need to now go through it and try to glean what I can.
I don't think this is right. This is a humongous number.
Well, but you think about it, our number to start with was 200.
This is 1,536.
That could be that really could be the right answer, though. Couldn't
But I
it?
thought it was the number for just those that are going to margin of error of 2%. See, it's not like you're changing the margin of error that much. Just a minute. I have something written down that as you change the margin of error, something happens to the number that you need. As the margin of error goes,
See, I get 15.68 squared, so that's 245.86.
oh gosh, how are we getting all these different numbers? Okay, wait a minute, you guys. Listen to this. If the margin of error goes down, the margin of error goes down as the sample size increases. So in this case, our margin of error is actually going up, so you would expect the sample size to decrease. Correct? Because this is true. As the margin of error goes down, the sample size goes up.
Right. But
So in this case, because our
196 over M. 0.02. I just found that that
formula,
and then P is 0.21 minus 0.2.
You found the one I had.
Yeah, it's in chapter 17 summary.
all right, will you guys excuse me for a minute? My dog is outside somehow and he's barking his full head off.
Yeah, I'm doing. I got what you got, Jessica. I think 1,536.64.
Yep.
Well, let's put it in there and give it a whirl and see what the crap maybe.
I say, what does it hurt? I mean,
1,537, right? As we
uh-huh.
go up.
Yeah.
At this point, we just need to put it in there.
If it doesn't work, I don't know.
And so what we could do, then I have to change my data here, right?
Yeah, we'll have to change everything. Let's see.
So if I do that 1,537 in the N.
Wait, it would be, oh, we have to round up. That's right. Sorry. Just kidding. It has to be a whole number.
1,537.
7. Suppose.
And then our confidence level is 95. Null hypothesis is 0. Prior estimate of. Okay, we're gonna do the 1537 because that's what both of us, Jessica and I, got from those numbers.
Well, I got 1537, but I got 1537. Right? That's what you got, or did you
Yeah,
get
that's
153?
the number we're gonna use.
That's what we
All right.
all got. Yeah. So and,
All right.
and so I put it in. So N is now 1537 in my
Okay.
one sample Z test for a proportion in Excel.
Okay. Ooh, my
Can
dogs
that
are
even
smelling.
work? Yeah.
Yeah, but then it changes our Z score to negative 16.414 with a p-value of 1.
Yeah. Oh, p-value of 1? That's kind of unusual. They're usually less than 1. At
Right.
least with a p-value over 1. I just really think that's too large a sample size, but that does seem like the right formula.
It
I
says
think-
it says according to this it is, but just wondering. I don't know.
Wait, so are you still putting this into a 1 proportion test?
Yeah. I was just changing the numbers on the one sample Z test for a proportion.
So then your X is still 50? And your
X
N
is still 50 or N is 1537.
I don't know.
Would that be right though?
I don't think so. But I don't really know where else to go with this, quite honestly. No, I mean, it's a humongous Z-score. You're going to have like...
I don't think this one gives us the answers at the end, if you remember right.
Oh, that stinks. Oh, that really stinks. I think you might be right. All right. Okay, let's go back up to that one once more in 28. I mean, I kind of agree with you because you have that P asterisk on there, and that's how they gave that. But what if we use that other formula I had? It gave a number of 384.16. So what if we did 385 and all that other stuff? Does that give us more things that make more sense? I don't know that it will. Yeah, it's still got a pretty big, I don't know. I don't know about that. It's got the Z-score of negative 3.44, which is possible, but that's pretty big. The p-value is 1, which I don't think we've ever gotten a p-value of 1 in anything we've computed, have we?
I don't think so either.
Yeah, so I'm thinking something's still not right. Well, all right, we might just have to contact her and say, can you tell us what we're doing wrong here? We've gone over it and over it and over it. Or I think I have another person's contact. Well, now it's so late. I don't know that I could contact her. She's in my time zone. To see if they've already gone over it in their group. Well. Okay, so what did you guys do? What did you decide to do?
It says a value of 1 for a p-value is impossible.
Wait,
Okay,
I
right.
thought a p had to be between 0 and 1.
Yeah.
I'm just reading what I just Googled, so...
Yeah. Okay, well, I don't think we're right anyway.
I don't think it is either, but it just is, that's the formula you use, so I'm just confused.
Yeah. Me too. Well, let's move on, okay, you guys? Oh, shoot, how do we know whether we're going to graduate from this? Oh, gee. We're going to say yes. We just will have to make a guess on 33. I mean, I'm putting in zeros for the one that we did.
We don't have, so our test statistics for 31, we don't have a test statistic for that either then.
I know. So 33, we're just going to be going off the cuff and guessing. And I'm going to say yes, that they do better than other investment managers because, you know, they're from the top 10 business programs. So
Yes, we rejected the no.
The null is that they get average, and so I think it would be a larger. So yes, no, it would be fail to reject the null, because the null is that they just do 20% or whatever it was. We think they did better. So I'm just talking out loud. Tell me if I'm thinking on the right line. So that would mean that the P statistic would
Good
be
enough
bigger.
for me. Yeah.
Okay, yes, failed to reject.
So this next one, we have to do the blue scores.
Wait a minute. On number 33,
34.
no, look back at 33. Do you see how some of these are rejected null hypothesis versus alternative hypothesis? Oh, that's right. With these, we use the null. Sorry. Okay, sorry. Or do we state it in terms of the alternative hypothesis? No.
I think that we're totally screwed on this test anyway, so it doesn't matter.
Okay, tell me what you guys picked for that one.
I put, yes, I failed to reject the null. I put the second one.
Sounds good. All right, sorry. We can move on to 34.
Yeah, I'm not happy about this because it's definitely not.
Okay. Oh my gosh. Oh, this was something we did in one of the sample things we read, huh?
Yeah.
Okay. Man, where was this? This was on test 2, wasn't it? Well, of course it was, because we're on test 3 now. But I mean, it was in the second unit.
Right.
And that ended up at 2 means independent data, didn't it? I think our first test was just the 1 mean, those 2, and then that. Okay, if we put this in, 95% confidence error on SPSS, I don't even remember what it is we're doing. What is it they want to know? Input lower and upper bounds. And then they're going to want degrees of freedom, test statistic, and p-value.
So what test is it? Because I have it pulled up. Analyze, compare means. Is it a?
Which?
We're on 33.
34.
34.
Sorry, I was still trying to figure that one out. So I'm like, wait. Not there. Okay. So, oh, it's one of the.
Is it a 1 sample? Yeah, because there's just the 1 set of data, right?
1 sample t-test.
That's what I think.
Are you guys are on 34, right?
Yeah.
Yeah.
Isn't there a link to do it in SPSS?
Yes, but we're in SPSS and we're just trying to remember what do we do with the data.
I already pulled it up. So if it's a 1 sample, then our lower is 0 or a 0.28238.
Don't you have to put something in the test value or no?
Yeah, well, I just had to move it over.
Okay.
But who knows? I'm getting tired of doing this test.
I am very tired, and this is only our practice, and we still didn't even, I'm sure we didn't rock it. I thought we were doing pretty good till we got to the end here. Yeah,
we're not even at the full end. My whole computer just locked up, so I hope I don't lose you guys.
Oh gosh.
Degrees of freedom are 99.
It's a total white screen.
Oh no.
Is that what yours is, Naomi?
Yes, it is. Would you read to me what you have again for upper and lower bounds?
I have lower is 0.282.
Okay, that's what I have.
And upper is 0.293 because I rounded up.
That's what I have. Yeah.
Degrees of freedom is 99.
Hang on a second. I'm inputting them because I can't get my screen to split. So number 35 is 0.293. That's the lower bound?
That's the upper bound. Lower is 0.282.
Okay.
And so number 35, the upper bound is 0.293.
Okay, got it.
36 is 99.
Jessica, can you hear us?
I can hear you. I'm just
Uh-oh, you just cut
Let's
out.
see, the test statistic is 109.
Let me go back to mine and look and see what it says. Okay, here's what I think we need to do. When you go back, well, just a second. Let me read that thing again, the whole question, and see. Confidence interval, population mean score of 0.295. Okay, I think I have an idea. Let me just rerun it, and then I'll tell you if I'm right or not. Okay.
Okay.
Okay. Go back and reanalyze this. So
Okay.
analyze, compare means, one sample t-test. So you
Okay.
moved your variable over, that says blue scores.
Right.
Underneath that big box, it says test value, and right now it says 0.
Oh, right.
We need to put that thing in that said 0.295. Now everything should be different than what it just was a minute ago.
Oh, but that makes sense.
Okay, so our t-score is
That's
now...
a better, our better t-score. So our t-test. So what did we have to change on that one? We had to change on the one sample, we had to change the test value.
Yes.
That's right. I forgot about that. Okay, so our lower bound is negative 0.126.
Ooh, I'm glad you said negative. I would have just written it down wrong. Yep. Ooh, upper's even negative.
Is it so 123, 0.13
On the upper?
on the lower?
Lower is, isn't it, negative 0.016?
It's negative 0.0126. So it would be negative 0.013 because that's to the third.
Wait a minute. Okay, 0.0. Oh, wow. Where was I looking? Oh, I was looking at the upper. Okay, wait a minute. Lower is negative 0.013. I agree. And upper is negative 0.002. Is that what you get?
Yeah. So then our test statistic is a negative 2.83, which makes more sense. Oh, wait, 803.
Okay. Yeah, now I'm going to go over and enter those onto the test itself. So 34 lower bound is negative 0.013. 35 is negative 0.002. 36 is still 99, isn't it? The degrees of freedom, that didn't change.
Mm-hmm.
Then our test statistic is negative 2.803.
Mm-hmm.
Okay. And the p-value?
I'm putting it in the applet right now, is 0.005. If you're shading both sides.
Okay, I'd have to go back and read what it said. Let's see if we're doing both sides. Oh, yes, this is not the 0.295, so yeah, both sides, I agree.
So then it's 0.005.
Okay. It's exactly, oh no, it's not, it's less. So it's less, so then we will reject the null hypothesis, right?
Yeah.
Means
So
we have sufficient evidence to reject, doesn't it?
Yeah. We have sufficient evidence to say that the true mean is different.
What problem are you guys on?
39.
39.
Okay, sorry, I'm still locked up, so I can hear
Oh.
you, I just can't do anything. But I don't
Oh,
care
I'm
to
so
close
sorry.
anything down because I don't want to lose our chat. So
Okay, I appreciate that.
I'm like, I'll just sit here and
Okay, so let us give you the answers again for this other stuff. Did you get
Well,
those, Jeff?
let's have somebody submit it, and then I'll
Okay.
write down the right answers.
Okay, we're not
Okay,
there yet anyway.
let's
so-
go to, to question
40.
40 then. And this is the AM PM heights.
Okay, so this one is going to be the difference, right, between two means.
Mm-hmm.
So that's going to be two means independent data. That's the one I don't have the stuff written down how to do it. I don't know what I'm doing on this one.
Can't we
you
do
guys.
that in Excel?
If you want, I don't know how to do it.
Maybe my
But you have to enter all that stuff. It's already pre-entered into this one. I'm going to see if it's the same thing as paired data. Wait,
Well, AM and PM heights, let's see.
an independent sample t-test.
Isn't it paired sample? Because it's the same person morning and night.
Oh, yeah, but yes, you're right. You're right. You're right. Exactly. Good job.
So then we have to say, is it the morning minus the night? Yes.
No, it would be the night minus.
No, it says right here, define the differences as AM height minus PM height. So
Perfect.
in the,
Minus. So to do that, you transform, compare variables. That's how you subtract the two column data, right? Move the
Right.
variable, and then okay. All right, I had a little glitch here, so I'm reopening it. Okay, so then I have transform, compute variables.
oh, that's what I did wrong. I got to do that. Okay. Transform, compute the variable.
That's what I thought it was, but then
Yeah,
I don't
yeah.
recognize
No, you're right.
what it, oh, there it is. Okay. So, shoot, is the first column, oh yeah, the first column is AM. And you said it's AM minus the PM?
Correct.
Okay. And this
And
is
the
on that
target-
little list of notes, or in that box, you know, in that big,
Yeah.
thingy? Yeah.
What's our target variable?
Just
The
a minute.
difference.
Yes, you just write down what it is.
Yes. Okay. Then with that, we can do our
Say
format.
right?
Analyze, compare means, paired sample t-test.
I think you're right.
Difference.
So we'll put difference in, wait a minute, when
It's
we're
not that
there,
one. What is it?
oh, well, here. Histogram graphs. No, wait. Yeah, I show histogram. So it's under graphs, legacy, dialogues, and then histogram. And then the variable in the box. The differences. And then, okay, let's see what this does. Hey, Jessica, can you read what the questions are on the test, or no, you can't? Okay.
let me see if it'll let me pull it up now. I'm trying to get to it. It's not cooperating very well. This white
So
screen.
I come up with a mean of 9.59 a standard deviation of 2.736 and 41 samples.
Yeah, but it doesn't give us the, that one doesn't give us the upper and lower bound.
Yeah, it does.
Oh, that's what I was just going to ask you. What is it wanting us to
Okay.
do?
I finally got my SPSS to open, but some of my other pages are still white and won't open.
Okay.
And I did the paired sample test.
Well, that's what we had tried, and we
And
didn't.
I got a lower bound of 8.72782 and an upper bound of 10.45551. And I got the same mean and same standard deviation as you guys.
Okay, your lower bound was what?
8.728.
Okay, and upper was 10.451.
455.
455.
Yeah, and I got that if I put it in just, but we didn't do the difference.
Okay, what else the difference?
Why did we have to do the difference? What does that mean? I don't understand why I had that written down that we had to do
Yeah,
it.
because that's the only thing. I'm going to put these in before I submit, but it's ringing a bell that you have to do the difference.
But I don't know why either.
Because if we do the paired sample t-test with that, then what was our standard deviation or the test statistic for the one before that, when we did the histogram?
Oh, it doesn't
Oh, it doesn't
give you
need
the
it.
test statistic, but it does give you the standard deviation of 2.736 on the histogram. The mean is 9.59.
But see, the test statistic on that says 22.446, the T.
And that was doing it as analyze two variables, you mean?
Yeah.
Yeah, it does. I see that.
So I think that's
remember,
wrong.
remember where there was a certain box where you had to not look in one row? Do you remember what it was? Is this one it? No, this doesn't have, never mind. I don't know. All right, let's go back to this. The lower bound is 8.728. One is 10.455. 42 is, oh shoot, I didn't write down the test statistic. What was it?
22.446.
And then the degrees of freedom?
Degrees of freedom are 40.
And
That's
the
where you
p-value?
get the subtract. Remember, that's where you're getting the subtract thing. Degrees of freedom are the number of things subtract 1.
Oh, that's right.
That's
right.
why that's ringing a bell. That's how you get your degrees of freedom.
Yeah, but no, she was saying the two columns of data, the before you started the weight loss program and after you started the weight loss program.
Give me just a second. Yeah, but
And I don't know if,
let me see. Scroll down and see if I get more information. No. Okay, so what do we need to know next?
The test statistic.
yeah, the p-value.
No, the test statistic is the T.
Which is
And
22.
Wait a minute, where are you guys? What
On
number?
question 42.
Oh, well, I already did that one.
On the poured sat. But see, that seems like a really high test statistic.
It does. I agree with you. But I think it's right.
Well, I'm putting it down for kicks and giggles, and we'll see what happens.
Okay. And what did you say, Jessica? Well, I'll go back and tell you the.
Yeah, what do
Degrees of freedom are 40.
Yes.
Yes. And the p-value is 0.
Yep.
And then is there not enough evidence because we rejected the null? Which one is this?
Okay, so let's see. It is less, so we will reject. So there's sufficient evidence.
Yeah, it restarted. I just had to reopen my quiz now. It reopened finally.
Based on your results, is there enough evidence to suggest children are taller in the morning than in the evening? Yes, isn't it? Because we rejected it, there is sufficient evidence. The third one?
Yeah. I think so.
All right, are you submitting, Cody?
Yep, I'm submitting.
I am
Oh, wait.
really aggravated about this whole
I wonder
thing.
how painful this is going to be.
What did we put as 28? What was our margin of error we decided?
For number 28, just a minute. I think that was one of them that we didn't know.
Do we need to go
28,
back?
yeah. I put a 0 in because I don't know. That was one we could
Okay,
never
I'll just
figure
put a
out.
0 in and see, because that was one I didn't answer and it wanted me to answer
I don't
something.
think it gives us the answers though.
I'll see. I'm submitting right now. We're gonna fail in an epic way.
After having spent 2 stinking hours on this.
That
Oh
and I
my
have to go after
stars.
we. Okay, how bad
Yeah.
we do?
So we got 62%. We got 27 out of 43.
Okay,
Oh my God.
let's write down the ones we got right. I have to get home. My kids.
I have to too. Okay, so you know what I could do? Let me print it out and then just text it to you guys.
Okay.
That would
that's
work.
fine.
And then Cody,
That's
let
fine.
us. If as long as you don't care to submit it again, let's all. I'm trying to think. I can't. I'll probably take my test. I'll just take it Wednesday after work. So my thoughts are tomorrow evening. After I get my kids to bed, I'll try to work on this. And maybe
Yeah,
if
I
we all
think
work,
Yeah,
We could.
this is
Oh.
17 pages long.
Oh my goodness.
So I'll print it, but maybe what I should do is
you want to just tell me the answers? I'll write them down. I'm okay if you want to just tell me them.
okay. Do you want to do that too, Naomi? Or
I want to.
because I don't mind, sending pictures. It's just going to take, because we didn't get any of the, okay, number 2, we put test of 2 proportions and that was wrong.
Oh, shoot.
Number 3, we put the chi-square and that was wrong. Number 4, we put 1 sample z-test and that was wrong.
Oh my gosh. Wait,
Number 5, we put paired sample and that was right. Number
Just a
6,
second,
we
just a
put
second,
paired,
sorry.
okay.
Number 4 was test of 1 proportion and that was wrong, right?
1 sample z-test and that was wrong.
On number 4?
Uh-huh.
Okay. All right. 1 sample Z. Okay. And sorry, I'm a little slow here and that was wrong. Okay. And 5
No problem.
was
5 we got right. It was paired sample t-test.
okay.
6 we got right. It was paired sample t confidence interval.
6 paired T. Okay.
7 we got wrong. We put independent samples t confidence interval.
Okay.
8 we got wrong. We put confidence
Oh.
interval for 2 proportions. I just don't get these then.
I don't either because I think the way we had
9 we got
explained it-
wrong.
Oh.
9 is we put the probability of rejecting the null hypothesis, whether it's true or not, we got wrong.
Okay.
10 we got right. It was number 3, the probability of observing a sample statistic more extreme than the one actually obtained. 11 we got right. 95% of all 95% confident intervals actually contain the true mean. 12 we got right. We put 0.3. 13 we got wrong. We put 0.0055.
Oh, see, and I think the answer might be 3, you guys, on that one. So,
Yeah.
okay.
14 we got wrong. We put 0.
14. Yeah, obviously.
15 we got right. The margin of error is 0.016. 16 was right at negative 0.003. 17 was right at 0.029. 18 was right with the null hypothesis, P1 equals P2, and the alternative hypothesis is P1 is not equal to P2. 19 we got right at 1.458. 20 we got wrong at 0.928. 21 is wrong at yes, I failed to reject the null hypothesis.
Just a second. Okay.
22 we got, I don't see Jessica anymore. 22 we got right at 6.579.
Just a minute here. I missed something. Oh, that was 21. Okay. Sorry. 6.579 is correct.
And 23 is correct at 0.087. And 24 is correct at no, the p-value is greater than 0.05, which we totally guessed at. 25 is right at we have insufficient evidence to say that being a learning person is not independent of age. So 26 is correct at 0.19. 27 is correct at 0.31. 28 is obviously wrong. I put 0. 29 was correct at the null hypothesis is p equals 0.2 and the alternative is p is greater than 0.2. And 30 is correct at NP is greater than or equal to 10 and N times 1 minus P is greater than or equal to 10. 31 is wrong, we put 0. 32 is wrong, we put 0. 33 is wrong, we put yes, I failed to reject the null hypothesis. 34 is wrong at negative 0.013.
Just a second. Negative, just a minute. What do we have? Negative 0.013.
Yeah, 0.13.
And that's wrong, you said.
Yep. And 35 is wrong at negative 0.002.